Hello and welcome to this video where we are going to be going through the 4 worked solutions to this sample paper. This is a sample paper for the Edexcel IGCSE Modular Pathway Unit 1, so the unit that you do in the first year of the new modular pathway. I created this paper myself, so just in case anyone's watching this, if you haven't tried this paper already, I will put a link in the description where you'll be able to download it, and I will also link to my previous video that I did on the actual official Edexcel sample paper. I am also making a further sample paper as well, paper 2, so I will link that down in the description also, so you should have access to all the resources you need. And then once you have had a go, watch this video and feel free to skip ahead if there is just a particular question that you are stuck on. Okay, so we'll crack on. For question 1 here, we are asked to show that 3 over 8 divided by 7 over 12 is equal to 9 over 14. So this is a show that problem, so it means we want to show all our methods. We could just type this into our calculator and get the answer, however that unfortunately won't get us any marks. So we want to show that we know how to divide fractions, and to do that we are going to keep the first fraction as it is. We will change this to a multiplication and we flip the second fraction so it becomes 12 over 7. Then we multiply, so 3 times 12 is 36. We multiply the bottom as well, so 8 times 7 is 56. And then now I need to simplify this down. So we can divide 36 and 56 both by 4. And I will show my workings here just to be really clear to my examiner that I know what I'm doing. So we divide that by 4. And so then this is 36 divided by 4, which is 9, over 56 divided by 4, which is 14. So for this question here, we have diagram shows a shape. The shape has this area of 129 centimeters squared, and we want to work out this value here, x. This is a composite shape, so to work out the area, we need to split it up into 2 parts, and you can either split it along there into 2 rectangles, and then you can add together the area of each, or you can split it down here, which I think I like the look of better, so I'm going to do it like this. And so for the rectangle on the left, the area of that is 9 times 12, which is 108. And then for the area on the right, this rectangle, this is x times whatever this distance here is, which is not immediately obvious to us, but we can work it out because we know that the full width of this rectangle here is 9, and we're also told that this part here is 6, which therefore means that this part here is 9 minus 6, 3. And so then the area of this rectangle is going to be 3 times x, which is 3x. And then we're just going to add together these 2 parts. So I have 3x plus 108 is equal to the full area, which I'm told is 129. Now we can solve this equation for x. So first of all, I'm going to take the 108 onto the other side and I subtract. So 3x is 129 minus 108, which is 21. And then I divide through by 3, so x is 7. Maybe we will put the units there as well, just to be complete, because it is supposed to be x centimetres, but I don't think you'd lose marks with or without the centimetres there. Okay, on to the next question. So here we have an algebraic fraction. I don't like this 6 here. Whenever you have any fractions you're trying to solve, if you have any kind of fraction, just multiply up by the denominator to get rid of the fraction. So we're going to take this 6 and multiply everything by 6, which will leave 2x plus 5 on the left. And then I multiply this side by 6. I have 6, 2x minus 5. Now my next task is to expand this bracket. So I have 2x plus 5 is equal to 12x minus 30. Now you can see I have some terms that have x in them, some terms that are just numbers. I want to get all the x's onto one side, all the numbers on the other. So what I'm going to do is I'm going to take this 2x here onto the other side, and I'm going to subtract 2x from both sides. So this is now going to be 5 is equal to 12x minus 2x, which is 10x, minus 30. Now again, I'm going to take this 30 here onto the other side. This is a minus 30, so I'm going to add 30 onto both sides, or you can think about it as moving that 30 onto the other side and adding. So I have 35 is equal to 10x. And then lastly, now I'm going to divide through by 10. So x is 35 over 10. You could leave it like this if you wanted, or you can write it as a decimal. X is 3.5. Now we have some indice problems. So here to simplify these indices, when you have the same base, so by that I mean this h thing here is the same. If you are multiplying, you are going to add the indices. If you are dividing, like we are here, you are going to subtract the indices. So we are going to have h to the power of 15 minus 3, which is 12, is h to the power of 12. Now here, if you're raising something to the power, everything inside this bracket needs to be raised to the power of 4. So 2 to the 4 is 16. Then you have g to the 3 to the 4. Now when you are raising something to another power, you're going to multiply these two numbers together. So this is g to the 12. And then again, the k is also being raised to the power of 4. So k to the 5 to the 4 is k to the 20. You multiply the 5 and the 4 together. So this is 16 g to the 12 k to the 20. And the last problem here, so here we have this unknown thing n, which I'm trying to work out. There's probably two different ways you could approach this problem, because you could try and multiply up here onto this side. I think what I'm going to do is just sort everything out on the left, and then we'll set it equal to 12. So first of all, we are multiplying these two indices here together, and when we multiply, we add the powers. So this is y to the 5 plus n over y to the 7. And then now this thing here is a division, and when we are dividing, we subtract the powers. So I have y to the 5 minus 7, so 5 minus 7 is negative 2, plus n. So I'm taking this indice here, 5 plus n, and I am subtracting 7. And when you do 5 plus n minus 7, you end up with minus 2 plus n. Now we are solving this equation because this is just the thing on the left-hand side, and we know that this is still equal to y to the 12. So therefore, minus 2 plus n is equal to 12. And then I add 2 onto both sides, or you can think about it as moving it over there, changing that negative to a positive, and so n is 14. Okay, now we have some factorising here to do. I'm noticing that 18 and 27 are both divisible by 9. So I can take 9 out the front. 18 divided by 9 is 2, so it's 2c. And 27 divided by 9 is 3, so that's negative 3. Just be careful to take out 9. If you take out 3, then you will need to take out another factor of 3 afterwards. Expand and simplify. So there are a few different methods you can use for expanding brackets. You could use the grid method, you could use FOIL, or you can use a smiley face. It is up to you. I think I am going to go with a grid method this time. So I'm going to put the first bracket up here, t and negative 4. The second bracket down here, t and 5. And then we multiply it into the grid. So t times t is t squared. This is going to be minus 4t. This is 5t. Minus 4 times 5 is negative 20. Now everything that I just multiplied, I'm going to write out in a line and add all those terms. So we have t squared minus 4t plus 5t minus 20. And then I can simplify here because I can collect these two terms together. So this is t squared minus 4 plus 5 is plus 1, so plus t minus 20. So here we're asked to find the midpoint of 2 points A and B. To work out the midpoint, what you do is you add together the two x coordinates, so x1 plus x2, and divide by 2. You're essentially taking the average of the x coordinates, and then you also take the average of the y coordinates, and that will give you the midpoint. So first of all, I'm just asked for this midpoint x here. So I'm going to take the average of the two x coordinates. So this is 11 plus 1 over 2. 11 plus 1 is 12. 12 divided by 2. 12 divided by 2 is 6. And so x is 6. Then we do the same thing for the y coordinates. So we're going to add together the two y coordinates and divide by 2. And so this is going to be 3e plus 7e, all divided by 2. 3e plus 7e is 10e, all divided through by 2. And then I can simplify that because I can divide 10 by 2 to just give me 5e. So y is equal to 5e, which is fine because it asks for an expression for y in terms of e, which I'm done. We're not asked to actually solve y completely. Next question, number 6. So we have a holiday rent. We are told that £530 is the same as €715.5. The weekly rent for a holiday cottage is £750. Using the same rate of exchange, work out the weekly rent of the cottage in euros. So I know that £530 is equal to €715.5. Now I want to work out what £1 is going to be worth, and then eventually I'm going to work out what £750 will be worth. So to get £1, I have divided here by 530. So I'm going to divide the other side also by 530. And so you get £1 is worth 1.35 euros. And now we build up. So I didn't actually want £1, I want 750. So what are we going to do now? We're going to multiply by 750. So I multiply this side by 750. And so 1.35 times 750 is 1,012.5 euros. 1012.5. So for question number 7, we have a Venn diagram. We are given some various pieces of information and they want us to fill this in for the Venn diagram. So this here is the universal set. So what this means is that all of these numbers need to go inside my box somewhere, whether they're in A or in B or on the outside. And then I'm also given the intersection, which I think is where I'm going to want to start off here. So this is A intersection B. So all those numbers can just go straight in the middle, 5, 10, and 15. 5, 10, and 15. Okay, now what I would do if I was doing a question like this is I'd probably cross off these numbers from the universal set just to remind myself that I have put them in the Venn diagram. And now we can tick this off and move on to the next piece of information. So I know that all these numbers are not in B. So 7 is not in B. Is it in A? So I'm going to have to use both of these at the same time actually, and I can see that I have 7 not in B and not in A. This is the complement, so it means that it should not be in B and it should not be in A, so it means it needs to be on the outside here, and I have done 7. What else do we have? 8, so I can see that 8 also is not in B or in A, so 8 needs to go on the outside like this. 9 is not in B, but I don't see it in this list, so that means it must be in A. 9 is also done. 11 is not in B, and again I don't see it in the bottom list, so therefore 11 must be in A. 12 is not in B, but it's not in the bottom list, so it must be in A. 13 is not in B as well. And 13 is not in the bottom list, so it should be put in A. 14 is not in B, and it is also not in A, so this is going to go on the outside again. And I think I've done most of the numbers here now. I can see some stuff in my universal set that I haven't crossed off because I was going down this list here, not B. And so I need to still do 4 and 6, and I can see for both 4 and 6 they are not in A. But they're not in that not B list, so they should be in B, 4 and 6, and we are done. Just be careful here that this complement part, B complement means all the things that are not in B. It can be a little bit confusing. Okay, on to the next question. Some more indices here. So we have y to the power of 0. Well, anything to the power of 0 is 1. And if you get confused in your exam, you can always just use your calculator to test some values. So put in 2 to the power of 0 on your calculator, you'll get 1. Put in 10 to the power of 0 on your calculator and you'll get 1. And hopefully that will kind of remind you of the rule. So if y to the 0 is 1, we have 2 over 1, which is just 2. Simplify this. So again, we have an indice on the outside. This needs to come in. Everything needs to be raised to the power of 3 over 4. So if you raise 16 to the power of 3 over 4, you could just type this into your calculator, or you can actually manipulate this indice a little bit. That number on the bottom, the 4, becomes the root, and the number on the top becomes the power, so it's all to the power of 3. And the fourth root of 16 is actually 2. So this is 2 to the power of 3, and that is 8. But again, you could just type this into your calculator. Your calculator will tell you it's 8. And then we are going to raise a to the 4 to the power of 3 over 4, which means I need to multiply these two numbers here. I'm doing 4 times 3 over 4. Which is a to the power of 3. The 4s there will cancel with each other. And so the answer is 8a to the power of 3. Now we are expanding some brackets, and here we have 3 different brackets, 3 different terms that we need to expand out. You can choose where to start. I think I will start off just looking at this, the 2 brackets there at the end, and expand those. I think last time we did grid. Should we do a smiley face this time? So I can do the eyebrows, I can do the nose, I can do the mouth. So here I have 3x times 2x, which is going to be 6x squared. And then we have 4 times 2x, which is going to be plus 8x. I have 3x times negative 1, that's minus 3x. And lastly, 4 times negative 1, which is negative 4. Now we are going to simplify this, and I can collect together these 2 terms here. So we have 6x squared plus 8x minus 3x plus 5x minus 4. Now, problem, we have this 5x on the end, which I've kind of ignored, but all of this should be multiplied by 5x. All of this needs to be multiplied by 5x as well. So we go through and multiply each term in turn by 5x. So if I multiply these 2 together here, this is going to be 30 x to the 3. And then if I multiply these 2 terms together, this is 25x squared. And then 5x times negative 4 is going to be minus 20x. And that's my solution. Actually, wait, we can just do an arrow there. That goes on the dotted line. Next question. So here we have a table, and we're asked to draw this thing here, which is the same as this thing here. So my table is going to help me to do my drawing. And so first of all, we need to put minus 2 into this equation here. What you're going to need to do here is use your calculator, and you are going to type in minus 2 cubed minus 3 times minus 2 plus 1. So instead of this x here, you are putting in negative 2 into those places. Be careful to use the brackets on your calculator, the same as I've done here. If you don't put in brackets, your calculator will mess up this bit here. It will actually, no, in this case it's the same, but just be careful of that. So if you don't put the brackets in, the calculator can get confused and you can end up with incorrect answers. So if you type all that in, you will get negative 1. And then you do the same, but instead of this minus 2 here and here, you can just edit that on your calculator and change that to a minus 1 in both places, and you will get an answer of 3. And then we are going to put 0 in everywhere, which both of these terms then very conveniently will be 0 minus 0 plus 1, and so you just have an answer of 1. And then lastly, inside these two brackets here, you are going to put 2, and then substituting 2 in everywhere, you get an answer of 3. Once you've done your table, it's time to draw your graph. So you're going to have to plot these coordinate points. So for the first one, you have x2. So this is the x-axis here. So x2 is here, and then y is -1. So at 2 minus 1, you're going to draw a small cross there. And then x -1, y 3 is going to be there. X 0, y 1 is going to be here. And then x1, y -1 is here. And then lastly, x2, y3 is going to be here. And so you can see this graph initially might look a little bit weird. It kind of goes up and down, and that's because this is a cubic. So you should know the general shapes of the graphs. If you have something that has an x squared, then you have either a happy or a sad quadratic, which forms a curve like this. If you have an x cubed, then you will have either a positive x cubed or a negative x cubed, which will look something like that. And you should know the rough shape because you might get questions that come up like this, where they ask you to kind of identify based on the shape of the curve. Or you get questions like this where you're asked to plot, and it will help if you know the rough shape, identify if you made a mistake. This looks good to me. It looks like a cubic like this, which is what I'd expect it to be. And then we're going to have to join up these dots in that kind of curvy shape, which I unfortunately do not have a option for a ruler, so I'm just going to try and do it freehand as nicely as I can. Although actually you won't use a ruler for this, will you? But you should join up all your dots into a smooth looking curve like this. Okay, on to the next question. So here we have 4 graphs. These are all different sorts of reciprocal graphs. So reciprocal graphs are things like 1 over x. And I'm asked to write down the letter of the graph that could have this equation here. So let's just summarize all of those 1 over x graphs for you in case you get a different type of question like this. So the graph of 1 over x looks something like that. The graph of -1 over x flips that into the opposite quadrants, so it looks something like this. And then you have the x squareds. So if you have -1 over x squared, this should be always positive. Sorry, not -1. If you have 1 over x squared, that should be always positive, like that and like that. And then if you have -1 over x squared, these should be always negative, so like this and like this. And so we are asked for -1 over x squared, so I'm looking for that last type. Where do I see that? That is this one here, D. Okay, on to question number 10. So here we have a diagram of a right angle triangle and a rectangle. The area of the triangle is twice the area of the rectangle. Write down an equation for x. Okay, so the triangle is twice as big. So what that means, this is twice as big. If I take the area of the rectangle, so that's just going to be length times width. So 7 times 10 minus x. And then I multiply this whole thing by 2, then I should get the triangle, which is 1/2 times the base times the height. 9. Now, actually, this is probably good enough. It just says write down an equation. It doesn't, in the equation, it doesn't really tell us to simplify it. It doesn't tell us how it should be. So I think even if you wrote this on your line, it should be good enough. I will simplify it slightly because there's some very easy things to do here. For instance, 2 times 7 is 14. And then I don't think I'll bother to expand the brackets, seeing as how we don't have to. But I'll write this as 9 over 2 multiplied by 8x plus 4. But if you have expanded the brackets and simplified it, it'll be fine. Any equation that would be equivalent to that will get you the marks. Work out the area of the rectangle, show clear algebraic working. So here we're going to have to actually solve this equation that we've written out to work out what x is. And I think, as before, I don't like when I have fractions, so the first thing I'm going to do is multiply that up by 2. So 14 times 2 gets me to 28. This is 10 minus x is equal to 9 times 8x plus 4. Now I'm going to expand out these brackets here. So I have 280 minus 28x is equal to 9 times 8x, which is 72x, plus 9 times 4, which is 36. And now we're trying to solve this equation, so I'm going to get all my values that have x onto one side and all of my values that have y onto the other. So what I would do is I would choose to leave that 72x where it is, and I'm going to take this 28x onto the other side and add it, which is 100. So this is 280 is equal to 100x plus 36. And then we will take the 36 over onto this side here. So I'm going to subtract 36. That's going to get a bit messy. So 280 minus the 36 is 244. And then dividing through by 100, I have x is 2.44. Now, once you've worked out what x is actually isn't the job done, because what we wanted was the area of the rectangle. So I'm going to go back up here and see that the rectangle is 7 times 10 minus x. And then I'm going to substitute in x as being 2.44 into here. So we are working out 7, 10 minus 2.44. And then we can just type that into the calculator and you will get 52.92. Okay, moving on to our next problem. So here this is a difference of two squares times a kind of problem. If you have x squared minus y squared, where x and y are square numbers, you can factorize this to x plus y, x minus y, like so. And in my case, the square numbers here are 3x, because if I square that, I will get to 9x squared, or you're taking the square root. Square root of 9 is 3, square root of x squared is x. And then here, if I take the square root of this is going to be 2y. So I have 3x plus 2y and 3x minus 2y. Express this as a single fraction in its simplest form. Again, I'm not liking the denominators, so I'm going to multiply everything up. And I think if I multiply this here by x, that would help me, because here I can see on the other side I have a 4x, so I want an x in the denominator at least. So let's multiply top and bottom by x. So we have 7x over 8x minus x plus 3 over 4x. So that's looking pretty good. However, I think that second fraction also needs to be multiplied top and bottom by 2. And then it will be over 8x. So we have 7x over 8x minus 2x plus 3 over 8x. Now I can write these as one fraction because the denominator is now the same. So I have 7x minus 2x plus 3 all over 8x. So I've done this bit writing it as a single fraction. However, I don't think this is yet in simplest form. I'm going to expand out that bracket. 7x minus 2x minus 6 over 8x And then let's collect those x terms. So 7x minus 2x is 5x minus 6 over 8x. And then I think that looks like all we can do. And so now it is pretty simplified. Right, on to our next question. Change 32.4 meters cubed into centimeters cubed. So when we are converting from meters to centimeters, we would usually times by 100. So if I wanted to change from meters squared to centimeters squared, I times by 100 squared. And if I wanted to change from meters cubed to centimeters cubed, we are going to multiply by 100 cubed. So I take the 32.4 and I times by 100 to the power of 3. And this gets me 324 and 1, 2, 3, 4, 5 zeros. So what's that? 32,400,000. So here we have a diagram of a sector. Work out the area of the sector. Give your answer to one decimal place. This question is actually pretty straightforward for us, I think, because we can just do the area of the circle, which is going to be pi r squared. And then we're going to take the area of that circle and multiply by the fraction of the circle that I have. And this is actually 110 out of 360 of a circle. The radius I have, that's 7.1. So I'm just going to substitute everything in. This is going to be 110 over 360 times pi times 7.1 squared. And you can just type that into your calculator and you get 48.4. So here we have a straight line passing through these 2 points, and we're told that M is perpendicular to the line and intersects the y-axis at the point 0, 8, and they want the coordinates at the point where M intersects the x-axis. So in order to work this out, we're going to have to work out the gradient of M and potentially the equation of that line, I think, as well. I can't get the gradient of M directly, but I can use the fact that it's perpendicular to the line L. And then I can get the gradient of L first because we have these 2 points here. So to work out gradient between 2 points, we are going to use y2 minus y1, so the difference between the y coordinates, over x2 minus x1, the difference between the x coordinates. So in my case, I have 4 minus the second y coordinate, so that's -1. So that will become a plus in a moment. And then we are going to do 6 minus 4 on the bottom. 6 minus 4, x2 minus x1. So this is 4 minus 1, which is 4 plus 1. So that's 5 over 6 minus 4, which is 2. So this is the gradient of L. I actually want the gradient of M. And the gradient for M, we are going to use the fact that they're perpendicular. So if you know 2 lines are perpendicular, you are going to flip the fraction and change the sign. So this is going to be minus 2 over 5. And now we also need the equation of the line. So I have y is equal to minus 2 over 5 x plus c. I want to know what this c value is. Now there's 2 different ways you can do this. You could substitute in x is 0, y is 8, or you could know that c is the y-intercept, and also this 0, 8 point is actually the y-intercept, because we're saying, well, x is 0, y is 8. That's the same as the y-intercept. So you could go in straight away and say, well, this must be 8 from that coordinate. If you don't notice that and you do a substitution, that's also fine. So we know x is 0, y 8. So I can put y is equal to 8 in here is equal to minus 2 over 5 times x, which is 0, plus c. Obviously, all of this is just 0. So you end up with 8 is c. And then we've got to the same conclusion here. So I can write the equation of the line as y is minus 2 over 5 x plus 8. Now this is the equation of the line, but actually the question asks for the coordinates of the point where M intersects the x-axis. and we intersect the x-axis when y is equal to 0. So when x is equal to 0, we intersect y, and then when y is equal to 0, we're going to intersect x. So I'm going to put y0 in here to work out what my x coordinate is. So 0 is minus 2 over 5 x plus 8. Let's take the 2 over 5x onto the other side. So I have 2 over 5x is equal to 8. I'm going to run out of space. Multiplying up by 5, I have 2x is equal to 40. And so finally, x is equal to 20. Now it asks for it as a coordinate. So we have x is 20, y is 0, because that is what we use to find x here. We know that y is 0 because that is where we cross the x-axis. Okay, so here we have a shape. We're asked to work out the area of this quadrilateral. And they've actually split it up into two triangles for us. So I think we're going to be using area of a triangle here. There are two formulas for area of a triangle. You have a half times the base times the height, and we used this formula earlier on in the paper. Or the second formula you have is actually given on the formula sheet at the front, and it's a half AB sine C. And I think this is probably the one we're going to be interested in because we are given these angles here. So using sine seems to make sense, and we're going to put the angles in here instead of this value here, C. Now, to use this formula, you need to be careful how you label your triangle. So it might seem at the minute like we've been given the angle here, B, but we can actually really easily just go ahead and label this angle C. We can leave this as being A, and so therefore this becomes the side A. And because this angle is C, this angle is A, the last one now is going to have to be B, and so this is going to become the side B. And it always works out like this. No matter how you label your triangle, this formula is always used. Any triangle you have, if you want the area, you need the angle, and then the two sides either side of that angle. Two sides, angle in the middle, you can work out area, and the labeling doesn't really matter. So now we can go ahead and substitute into my formula. So I have a half times A, which I call 12, times B, which we said was 9, sine of 60. And then you can go ahead and just substitute that into your calculator, and we get 27 root 3, or as a decimal, that is 46.765. So that's the first triangle. Now the second one becomes a little bit more problematic because we have this 84. I have this 7, so that looks good, but I need this side here next to the 84. And to get that, we're going to have to use cosine rule with the triangle at the top. So we have two sides. We have the angle in the middle, which means I can work out the side opposite that angle. And then once I've got that, then I can use that area of a triangle with sine again. So let's keep on focusing at the angle at the top, see if I can work out that blue side. Cosine rule is also given to us on the formula sheet. So we have a squared is equal to b squared plus c squared minus 2bc cosine capital A. Now what I actually want now is, because I'm trying to work out this side here, which is the small a, and then this capital A will be the side opposite, I'm actually going to relabel my triangle again. And you can just remember it's two sides and the angle in the middle, or if it helps you, then just change what all the sides are called or the angles are called to make it work. So this is the angle I have. So this one is, I'm going to call A, and then it doesn't matter which way round I label the other two. So let's just leave that as being C and change this to B, and then the side opposite becomes small b, and the side opposite capital C becomes small c. And now you can substitute everything in, and we'll be looking for small a, that blue side. So we have a squared is equal to b squared, that's 12 squared, plus 9 squared, minus 2 times 12 times 9 cosine of the angle, which is 60. And then we can just take all of this thing here and type it into the calculator, and you will get 117. Now remember, this is a squared, not a. So now we are going to take the square root of 117. which is 3 root 13, or as a decimal, 10.8167. Now we're still not done because all that did was get us this side. This is what we were looking for. So this is the 10.8 thing. And now we are going to use these two sides with the angle in the middle, the 84, and put that into a half AB sine C. So a half times 10.8167 times 7 times sine of 84. And then we type that into the calculator, and you will get 37.651. Now we've worked out the area of the two triangles. I have this thing and this thing. So for the total area of the shape, we're going to add those. This is 46.765 plus 37.651. And then what did it want it to? 3 significant figures. So that's 84.4. Okay, the next question is a bounds problem. Calculate the upper bound of A. Whenever I have a bounds problem, I would usually work out the upper and the lower bound of everything. You'll get a mark if you can just get one of these. So for the upper bound here, this is 9.65. Lower bound is 9.55. U, upper bound, is going to be 3.85. Lower bound is 3.75. And then lastly for T, the upper bound is going to be 1.845. I always just add a 5 on the end for the upper bound. And then the lower bound is 5 below. So 1.835. Okay, so once I've worked out all the upper and the lower bounds, then I can go back and have a look at the problem to see which ones I should select. So I usually use arrows just to denote if I'm going big or small. So for A, we are looking for the upper bound of A. So I want to maximize that. So to make A as big as possible, I'm going to have to take something very large and divide by something very small. So T seems to be the lower bound. That's the easy bit. So we are going to take the lower bound of T. But to make this top thing here as big as we can, so I want V minus U to be something very large, I'm going to have to take a very big thing and subtract a very small thing. If you have a lot of something and then you subtract a really small amount, you'll still be left with a lot. So we are going to take V big and I'm going to minus U small. And then I will divide by T small. Okay, so let's take the upper bound of V. The upper bound of V is 9.65. I subtract the lower bound of U, which is 3.75. And then I'm going to divide by the lower bound of T, which is 1.835. You can type that into your calculator and you get 3.22. Okay, on to question 17, probability tree. There are 52 cards in a pack, 12 are picture cards, and 40 are number cards. And then we want to, first of all, complete this probability tree diagram. So you can probably use fractions or decimals here, both are going to be fine. However, considering the structure of our problem, fractions are going to make a lot more sense. So picture cards, we have 12 out of 52. Number cards, we have 40 out of 52. And then we need to be careful, is she putting the card back in the pack or not? No, she keeps the card and then takes a second card. So when we take the second card, this is going to be only 51 cards left in all of these rows here, because she will have taken one regardless whether it's picture or number. And then we need to be careful about which case we are in. So here, when we're taking a picture card, we've already taken a picture card, so there must be one less. So there's only 11 picture cards left. However, the number cards, they're all still there because we took a picture. So we have the same amount of number cards, which is 40, but we have one less card overall. So it's 40 out of 51. Now let's go down the second branch. So here we took a number card. So therefore pictures, we have all of those still. So this is 12 out of 51. Number, we have one less. So this is 39 out of 51. And we're done. Okay, then we are asked to work out the probability that the two cards she takes are both picture cards or both number cards. Well, both picture cards, we are going to multiply together these two probabilities here. So we need to do 12 over 52 times 11 over 51. And that will get me the probability of picture, which is 11 over 221. And then we want both number cards, so we multiply number by number, and that gets me 10 over 17. And then we're going to add these two probabilities together to work out the probability that she takes a picture, or she takes number. And so we add. And this gives me a total of 141 over 221. Okay, we have another lines question. So we have a point A and point B. The line has this equation. Is the line L parallel to AB? So I need the gradient of AB and also the gradient of the line L. So the gradient AB, we are going to use y2 minus y1 over x2 minus x1. So we have minus 1 minus 3 over minus 2 minus 1. So minus 1 minus 3 is going to be negative 4. Minus 2 minus 1 is negative 3. Those negatives will cancel, and so we are left with 4 over 3. Now let's work out the gradient of the line L. So the problem for the gradient of L is at the minute this equation is not in the y equals mx plus c format. So we have 3y is equal to 4 minus 2x. And I want to try and rearrange this to y is mx plus c. So I think if I divide everything through by 3, y will be the subject. So y is equal to 4 over 3 minus 2 over 3x. Now we need to pick out what is the gradient here. The gradient is always the value before the x. It might be clear to see if I swap those around. So y is minus 2 over 3x plus 4 over 3. So y is mx plus c. So therefore the gradient is equal to minus 2 over 3, which is not the same as 4 over 3. So therefore these are not parallel lines. Okay, so in this question here we have a histogram question. They want us to use the information in the table to complete the histogram. So we already have one bar drawn here, and I can see that this bar runs between 150 up to 300. So it looks like that should be representing this class here, 150 to 300, and should represent 240 people. And the key thing to remember in histograms is that area of the bar is equal to the frequency. And that should be enough to work out anything else you need if you just remember that one fact. So here the area of the bar, well, the width is the class width. So the width of this bar between 150 and 300 is 150. The height, I do not know. That's the thing I want to work out, but I know that the area of the bar should be equal to 200. So what we're going to do is base times height is 240. The area should be equal to 240. So base times height must be equal to 240. So if we do 240 and I divide by the width, which is 150, then that should give me the height, which is 1.6. So this height here needs to represent 1.6 on my graph, and I think if I make each of these kind of small squares here 0.5, that will work out. So therefore this here is going to be 1.5, this is going to be 1, and then 1, 2, 3. This here is going to be 0.5. And that scale looks like it works pretty well to me. So now each small square is 0.1, and that indeed does make the height of the bar 1.6. We can fill in the rest. So this therefore should be 2. This should be 2.5. And right at the top here we have 3. Now I need to go ahead and draw in the rest of the graph. So again, the area needs to be equal to the frequency. So I need to work out the height of all of these bars. So I'm going to do 120 and divide that by the width of the bar, which in this case is 100. And so that's 1.2. So between 0 and 100, we need a height of 1.2, which is there. Going on to my next bar, so my next bar has a width of 50. I'm doing 150 minus 100 to work out the width of the bar here, so that would be 50. And so then to work out the height of the bar, I'm going to take the area, which is 140, divide by the width of 50, and that gives me a height of 2.8. And so here, this bar then needs to go up to 2.8, which is there. I can fill in my bar. And you will use a ruler to do this in your exam so that it is much neater than mine. Then on to the next one. So here we have an area of 80. I can divide that by the width, which in this case is 200. And this will give me a height of 0.4. So the bar between 300 and 500, which is there, needs to go up to 0.4. 1, 2, 3, 4, there. And then the last one here has an area of 20. Divide that by the width of, in this case, 100. And so that will have a height of 0.2. So this is only going to go up 2 small squares like so, and my histogram is finished. Next question, work out an estimate for the number of people who took more than 200 minutes to reach their holiday destination. Let's rub out these notes here. I think they're going to get in the way. So 200 is here. And I want the people who took more than 200. So it's going to be all of these people. How many people do we have there? 20. So I'm just taking that from the frequency diagram, so I'm sorry, from the frequency table. And then all of these people, so there we had 80 people, so let's add those on. Plus, I'm also going to need all of these people. And remember, frequency is just the same as area, so I can just work out the area of that shaded part there. And so this has a width of 100 and a height of 1.6. So the area of this thing here is 100 times 1.6. And that is 160. So we are doing 20 plus 80 plus 160, which is 260. And we can go on to the next question. So here we have a cuboid, and we are asked to work out the length of AG. So in this case here, we need to identify the line we are looking for. So that's that dotted line that they've already drawn in for us. And I can see I've got the base and the length and also the height of the cube. and I'm going to need to try and make a right-angled triangle such that I can work out that line. And I think if I go across here and then up, that will form the right-angled triangle that I want. So this is, draw it a bit straighter, I think, if I can. No, still not very straight. That will do. So we have our triangle here like this. This is C here, we have G at the top, I have A down here, and then I am wanting to try and work out this length here. That's going between A and G. Now CG we have, that's 3 centimeters. It's going to be exactly the same, yes? This is going to be 3 centimeters over here as well. AC we do not have, but I think I can use Pythagoras' theorem on the base, because I know if I know this is 5 and this is 7, so I'm just thinking about the base of the cuboid now, then I can work out this length here, which is AC, and then I can fill that in on this triangle here the same. So let's use Pythagoras, and I'm going to do 5 squared plus 7 squared, and then take the square root. And so this is the square root of 74, or 8.602. And so that now is this side length here, 8.602. And now I want to work out this length here, and I'm going to use Pythagoras' theorem for a second time. So we're going to take the square root of 8.602 squared plus 3 squared. And you can type that into your calculator, and you are going to get the square root of 83, which is 9.11. Now we ask for the sides of the angle between AG and the plane ABCD. So ABCD is just the floor. So what they actually want is this angle here between that line and the ground, which is going to be this angle here. And so this is a SOHCAHTOA kind of problem. And you could actually use any of the sides that we found. So we could use this 9.11, the 3, or the 8.62. SOHCAHTOA. So depending on which of the sides you decide to use will depend whether you use sine, cosine, or tangent. I think I'm going to use sine here. So I want the side opposite. Sine of theta is equal to opposite, which is this side here, 3, over the hypotenuse, which is this side here, 9.11. So you're going to type that into your calculator, and then you will need to do inverse sine of this, and you will get theta is equal to 19.22, or to 3 significant figures, that's going to be 19.2. So to go, you need to do inverse sine minus 1 of 3 over 9.11. Okay, we can go on to the next question. So here we have an algebraic fraction, and we are asked to simplify this algebraic fraction. For these kinds of questions, you are looking to factorize all of the quadratics, and then you just hope that some things will simplify. The way the questions are written, they should simplify, and it's asked to show clear algebraic working. So what this means is we need to show what we are doing step by step. And so what I'm going to do is take this thing on the top, 6x squared plus x minus 15. You could choose your calculator here to try and find the roots of this and work backwards to the factorization, and that works fine. If you're doing it longhand, like a pen and pencil method, we would first work out AC. So that's this first number multiplied by this last number. So 6 times minus 15 is minus 90. And then you're looking for two things that multiply to give this minus 90 and add to give this number here before the x, which is 1. And I think 9 times 10 looks like it works pretty well, because the difference between 9 and 10 is 1. So 9 times 10 will give me plus 90. I want minus 90. What happens if I do that? I think that works. So minus 9 times 10 is negative 90. And if I add these two things together, I will get plus 1. So what I'm going to do now is take that middle term there, the plus x, and split this up into minus 9x plus 10x. So we have 6x squared minus 9x plus 10x minus 15. Once we've done that, we are going to factorise the first two terms and the last two terms. So these first two terms are both divisible by 3x. And so this is going to be 2x minus 3. And the second two terms are both divisible by 5. And so that is also going to be 2x minus 3. And you should always have the two brackets here as being the same. Yes, the 2x minus 3 should be the same. And it is in my case. That's great, it works. So I have 2x minus 3 as being the first bracket. And then the two terms on the outside, so the 3x and the plus 5, form the second bracket. Okay, so that's my factorisation done just of the numerator. If you have found the roots and then you work on your calculator and you work backwards to the factorisation, that also works and you will get the full marks, but you must show the factorisation. And I also want to factorise what is on the bottom. So we have 12x squared minus 27. Well, 12 and 27 are both divisible by 3, so let's bring a 3 outside. And so this is going to be 4x squared minus 9. And this is another difference of two squares problem. So we have 3, the square root of 4 is 2, so this is 2x plus 3, and 2x minus 3. So I factorised the top and I factorised the bottom. Let's write it back out as a fraction. So the numerator is 2x minus 3, 3x plus 5, over, and now the denominator is 3, 2x plus 3, 2x minus 3. Now I'm looking for things that cancel, and I can see that I have 2x minus 3, top and bottom. So this is going to cancel, and I think that is going to be all. I can't cancel that 3x plus 5 with anything at the bottom. So we're going to have 3x plus 5 over 2x plus 3. And you can leave that as it is. This is simplified. If you expand that bracket on the bottom, that is also fine. Okay, so onto this question here where we have some complicated indice problem. And we're asked to simplify this and give my answer in the form 5 to the power of w. So I'm trying to find something, simplify it down to 5 to the power of something. And I can see I've already got some 5s in here. So I'm noticing that 25 is 5 squared. I think that's going to be useful. And I've also got the root 5 in here, which is the same as 5 to the power of a half. 30, I'm noticing is 5 times 6, and that 180 is probably the thing that I like the least, the square root of 180. Let's see if we can try and find a 5 somewhere in this. So when you are simplifying square roots, what you want to do is look for square numbers. If I can split this up into two things, so for instance, we could split it up into root 80 times root 10, because 18 times 10 is 180, so I could split it up like this. If I can find something that I can divide it by, which gives me a square number, that is going to be really useful. And I'm noticing that this is going to be divisible by 9. 18 is divisible by 9, so 180 must also be divisible by 9. So 180 is 9 times 20. And the square root of 9 is 3. So this is 3 root 20. Now, I'm also noting I can split 20 up into 4 times 5. So this is going to be 3 root 4 root 5, which I love because we're getting our 5 there as well. And the square root of 4 is 2. So 3 times 2, this is going to be 6 root 5. Okay, that's great. So let's write this out and replace that 180 with 6 root 5. So I'm going to write 30 times, I might replace at this point actually 25, I'm fairly certain we're going to need is 5 squared. So let's change that all to the 2x plus 7 over 6 root 5 times root 5 to the 4x plus 9. Great. And I can see that actually I can divide top and bottom by 6 now, because Obviously, we can divide this by 6, but 30 is also divisible by 6, and that's going to become a 5. Okay, so now we have 5 on the top multiplied by, and I think I want to simplify these indices. So I'm going to multiply these two things here together. So this is 5 to the 4x plus 2 times 7, which is 14, over root 5 times root 5 to the 4x plus 9. Okay, this is looking a lot better because I can see lots of 5s happening. Now remember, when you are simplifying indices, if you are multiplying two things together and they have the same base, so in this case they are both 5, then you can just add the indices. And so it's important here to notice that 5 is just going to be the same as 5 to the power of 1. So I can simplify that numerator by saying that this is 5 to the power of, and then I add the two indices together. So this is going to be 4x plus 14 plus 1. So that is 4x plus 15. And I can actually do the same thing on the bottom, because we have root 5 all to the power of 1 times root 5 to the 4x plus 9. So this is going to be the root 5 all to the power of, and I'm going to add those two indices, 4x plus 10. Now this is really close now to being simplified into just 5 to the something. I know that root 5 is the same as 5 to the half. So let's change that. We have 4x plus 15 over 5 to the half all to the power of 4x plus 10. Now I can do the same thing that I did before now on this denominator, and I can multiply a half by 4x plus 10. So this is 5 to the 4x plus 15 all over. Now multiplying by a half, I have 4 times a half, which is going to be 2x plus 5. And then lastly, I can use my division law. I know that if I'm dividing two things, I subtract the indices. So this is 5 to the power of 4x minus 2x, which is 2x, and 15 minus 5, which is 10. And so I've now simplified it down into one indice to the power of 5. And if you remember from the question, it was 5 to the w. So the equation for w is 2x plus 10. And we can move on. Okay, so for the next question, we have an area of a rectangle. The length is root 7 plus 1. Without using a calculator, showing all your work in, find the width of the rectangle. So the area is 18. The length is root 7 plus 1. And so I reckon to find this width, we need to divide 18 by root 7 plus 1. And this is where the show all your work in part comes in, because what they want us to do is show that we can rationalize. You could type that into your calculator will tell you the answer, but we want to show that we know how to do it without using that. So we're going to multiply by root 7 minus 1 over root 7 minus 1. We always just write the thing on the bottom and change that sign in the middle. So because it was positive, it becomes negative. So multiplying fractions, we do the top to multiply by the top over, and then the denominator is multiplied by the denominator. So root 7 plus 1 times root 7 minus 1. Yeah, and then I'm going to expand both of these brackets. So on the top, I have 18 times root 7, which is 18 root 7, and then 18 times negative 1, which is minus 18. And I'm also going to expand the denominator. So root 7 times root 7 is 7. 1 times root 7 is plus root 7. Minus 1 times root 7 is minus root 7. And then lastly, minus 1 times plus 1 is negative 1. And I do show my full expansion here, although you can do less steps than this and still gain your marks. So I cancel this out, plus root 7 minus root 7. And so I end up with 18 root 7 minus 18 all over, and then I have 7 minus 1, which is 6. And I am actually noticing that everything is divisible by 6 here, which is great because in the format that they want, I can see I don't actually have a denominator. So let's divide through by 6. So we have 3 root 7 minus 3. And so then that can be my final answer. Okay, moving on to question number 24 and our final problem. So here we have an equilateral triangle. Because it is equilateral, it means that I can say that all of these angles here will be the same and they will all be 60 degrees. That's going to be useful to me. Then we are asked for the total area of the shaded region. Now what I'm going to do is put a line in here. And if you have become stuck on this problem, I think pause the video again now with that drawn in and see if you find that helpful at all. So look at this triangle here. This is a right angled triangle. See if you can pause the video and have another go if you did get stuck. Okay, so looking at this triangle, like so, this is a right angled triangle and this side length here is x. And then this angle now, what I've done is I've cut this angle in half. So this is going to now be 30 degrees. And on here also 30 degrees. And then what we're going to do is use SOHCAHTOA to work out this base here. SOHCAHTOA. So the hypotenuse, I don't know, nor am I interested in working it out. It's the adjacent side that I'd like to work out, and I have the opposite, which means that I'm in tangent. So the adjacent side is going to be equal to the opposite side, x over tan of 30. And so what that means is that the adjacent side here is going to be equal to x over root 3 over 3. And so then this simplifies down to being 3x over root 3. Root 3. And so that, therefore, is this side here, 3x over root 3. Now you have a couple of different options here. Because we've worked out half of AB, you could double it, and then you'd have all of AB, and then you can do half AB sine C. Because it's an equilateral triangle, all the sides will be the same, and you know that this angle here is 60. Or you could use Pythagoras, and then you could use a half base times height. We could get the base by doubling the 3x root 3. We could get the height of the triangle using Pythagoras, and then you could do area of a triangle half base times height. I actually am going to use the fact that this splits up into 6 of these triangles here. So if you look here, we have 1, 2, 3, 4, 5, 6. 6 triangles, all the same area. So if I work out the area of this small triangle using a half base times height times the base, and the base is 3x over root 3 times the height, which is just x. That's the area of one of those small triangles. And then I'm actually going to multiply the whole thing by 6 because there's 6 of them. And then that will be the area of the large triangle. And so what you end up here is 6 divided by 2, which is 3 times 3, which is 9. So we have 9x times x, which is x squared, all over root 3. So this is now the area of the large triangle. Area of the circle is pi r squared. So we're going to take big triangle and we are going to subtract circle, pi, and then x is the radius squared. And now we are very close to solving our problem. I can see here that I've got x squared in both terms, so I can take that out. So it's 9 over root 3 minus pi, all multiplied by x squared. And so this is the value of n, that thing in the brackets. You can type that into your calculator, 9 over root 3 minus pi, and you get 2.05. And so this is the final answer for n. This is n, 2 3 significant figures. Okay, I hope that was helpful. I have made another sample paper for Unit 1, and so I will link that down in the description as well. So if you'd like to have a go at another paper, please download that, and I will make a video solutions for that paper as well. And I hope you all have a great day.